We've assembled here a great set of speakers who represent different areas of industry, who will be presenting their perspective on nanotechnology and its impacts in their work. I'd like to invite our four panelists, Neil Sarkar, President of ICSPI, Peter van Balguy, VP Marketing and Business Development at EcoSynthetix, Simon Guthrie, Lead Investigator at Christie Digital, and Adrian Cote, Senior Scientist at Xerox Research Centre of Canada. And next, I'd like to introduce our moderator for the day, Alain Francq. Alain is the Managing Director of the Waterloo Institute of Nanotechnology, where he's accountable for the business operations of the Institute and for developing international industry, academic, and government partnerships to enable commercialization and further research in nanotechnology. He holds several key executive positions in academia and industry, including serving on the board of directors of NanoOntario. With that, I'll hand it off to Alain and ask him to take it away.
Thanks very much. Okay, holy smoke, how to follow up that? I was sitting there thinking, could I sing the periodic table? And that ain't going to happen, Mark. It's not going to happen today. But then I also thought a couple of things. I was looking at the butterflies up there, and I thought of the butterfly effect. And I thought, that effect where something happens and a million miles away, or even a bunch of years away, something happens. And I'm going to predict that perhaps in about 2 years, the percentage of fourth-year design projects that have nanocrystalline cellulose on it will increase exponentially, and it'll be because of this, and you've all witnessed it. So that's my prediction for today. The other thought I was thinking is the industry panel is the only way to counterbalance that is to have 5 guys against your one presentation, maybe. So thinking about it. But what's nice about this and the format of this, excuse me, is that you've heard about ideas. You've seen where ideas are coming from elucidating, the very nature of materials. And this is about, how do you take those ideas and move them into the economy? How do you take the talent that is produced through graduate studies and through undergraduate studies, and how do they create jobs and manifest it to increase the quality of life in the country? So we're flipping the coin, your 10-cent dime, and looking at the other side of it. So today, we have 3 sections to this session. We'll provide introductions, we'll have a panel discussion, and then there'll be Q&A. So I need you to think. I need you to be listening and then ask some smart questions at the end. And I wanted to say, the Dean of Science was saying he was in China the other week. I was in just Ottawa yesterday at NanoOntario, and it was a wonderful presentation of research and industry and government, and you could see where nano was becoming a priority in Ontario. 1 week ago, I was in China, and we were opening an Ontario Jiangsu Nanotechnology Innovation Center in China, and it's essentially for industry or students who have an idea and an innovation, and they want to bring it from Ontario to China. And then just last month, we were in Brazil. And same sort of thing is representing Ontario, representing Canada on the world stage, and specifically looking for collaborations and the industry receptor capacity. That's what we want to hear about today. It's the receptor capacity for the ideas and the talent. And that's why we're up here today. So with that, the format will be, I've got about 6 or 7 questions here, but the very first one, really, it's about introductions. So rather than me introducing, what I'd like the panelists to do is, one by one, provide a quick introduction, give them a sense of how you got to where you are in terms of the path. Tell us about your company. Tell us about why you're there, and perhaps, if you can, what component of that is nano? Where does nano fit in the R&D tech maps of your individual industry or your company? So with that being said, maybe I shall start off right here to my left, Dr. Neil Sarkar.
Thanks. So I'm a co-founder of ICSPI, which stands for Integrated Circuit Scanning Probe Instruments. We sell a microscopic microscope, which is literally a microscope that's so small that you need another microscope to see it. So you might be wondering what's the point. So it turns out that for the type of microscope we sell, which is an atomic force microscope, making them a lot smaller, like millions of times smaller, actually improves the resolution and stability of the instrument. So a typical atomic force microscope is typically around 100K. We sell our instrument, which resides entirely on a chip, for about 2K, and the consumables are very cheap as well. So a bit about the history of the company. The research started as my PhD work here at the University of Waterloo, and the company was co-founded with Professor Rafat Mansour. And I guess our relationship to nanotechnology is that we really are banking on the success of the nano community, because this instrument really only serves people who want to see things that are way smaller than what you can see with an optical microscope.
Excellent, thanks very much. Dr. Van Balluwe from EcoSynthetix.
Yes, thanks, Alain. So, Peter Van Balluwe. I'm also a U of W grad. Going back a ways, I did my undergrad in chemistry and my graduate degree in chemical engineering. And as I was listening to this, I was just thinking, would I have followed that same path if I had to do it over? And the answer is probably no. I'd really sooner have a seat in the group that you're in, because it's such an exciting area. And then I thought later on, just very, very recently, after that rendition, I might even consider a seat at UBC. It sounds like a great place to be. So EcoSynthetix, I joined the company about 4 years ago. And it's been a very interesting ride. The company was started back in 1996 by two chemistry graduate friends of mine, Steve Bloembergen and John Van Leeuwen. And they took, we took the company public about 4 years ago, so grew it from an idea to something that had an IPO valuation of about $100 million back 4 years ago. So you can just see some of the potential that was created. And all of that is based on a technology that does have sort of nanotechnology at its core. So a little bit about the technology and what we do. We make new biopolymer materials, starting from something as common as corn, tapioca, or potatoes, and you take the polysaccharides from those, you put them through a reactive extrusion process, and you can eliminate the crystallinity, and then you can do some interesting chemistry on it, which is what we do in the reactive extrusion process, and really change the characteristics of the polymer to produce materials that have some really, truly unique properties. When it comes out of the extruder, it's like a particle. Nobody uses it like that, but when you take that product and you make a liquid dispersion out of it, then it unleashes the nanoparticle characteristics. So they have a very high surface to volume ratio, which gives it some of the interesting attributes in applications like coated paper, or wood composites. And that's really what the company, how it has sort of evolved over the last couple of years.
Fantastic, thank you very much. Simon Guthrie is the lead investigator for Advanced Technology Group at Christie Digital.
Hi, I'm from Christie Digital Systems, which is in a building down on Wellington Street right at the Expressway right here in KW. And we do a lot of things, but a lot of people think we do projectors, and that's part of our business. I can't tell you how satisfied I am to see that there are a couple of our projectors on the roof here. So thank you, I appreciate that. That helps my Christmas bonus. My role at Christie, I've been there for about 10 years now. And I got there in the traditional way. I watched a lot of Doctor Who and Star Trek when I was a kid, and so I did physics at UW and graduated from here a long time ago. One of my profs in 4th year told me I should do some grad studies because it lets you do anything afterwards, which other profs say it's hitting the snooze button on life, and they're both right. So I did a master's in physics in laser imaging, and that got me into some optical design, and that got me into Christie Digital, where we design these projection systems, and we generate light, and we manipulate it, and we put it on the wall in any form you can imagine. The images you see on the wall here are about the simplest possible rendition of what we do. We can project images on buildings. We can project them onto people. If you watch the Grammys in the last few years, you can usually see images projected onto the artists. So we do some really cool systems level solutions that include projectors, but that's not the whole business. The Advanced Technology Group within Christie is not developing products. We are looking 5, maybe even more years out into the future, looking for the technologies that are going to disrupt our industry. Because if someone's going to disrupt our technology, we'd rather it was us than the competition. So that is me and Christie in a nutshell. Oh, and we're about 1,500 people, and half of them are in Kitchener.
So Dr. Adrian Boudet from Xerox Research Centre, Canada.
Right, so Xerox Research Centre Canada, based in Mississauga. Where to start? So about 40 years ago, Xerox Corporation decided to focus all its materials innovation in a single research center, and they selected it to be in Mississauga. And part of the reason is that you were surrounded by a number of universities that were really strong in chemistry, material science, physics, and engineering. So between Waterloo, McMaster, up and down the 401. So what we do at XRCC is we really live at the front lines of the commercialization of materials. So we think about a lot of the things that Mark identified in his talk about what are really important aspects of or work that needs to be done to really bring these types of technologies to the market. So over those years, we've actually been contemplating nanomaterials to make inks and toners and other electronic materials that are important for the printing and copying business. And happy to see Xerox printers in the hallways up and down here too. So keep printing. But we're much more than a printer company now, right? So what we also look at is working with other companies to help them commercialize their materials. And so over the year, we've built this know-how and mindset, and now there's 7 startups that are co-located with us. There's a technology incubation center that's co-located at our research center. Organization of Sustainable Materials also located with us to help commercialize their novel green materials. Bring them to market. And then recently, what's been really exciting is that the National Research Council of Canada has announced that they will build their new Advanced Materials Research Lab on our property in Mississauga, and there'll be a big partnership between the NRC and Xerox. So we do a lot of different things. That's just a high-level overview of our kind of structure, and sort of how did I get there is I'm Waterloo graduate also, and my 4th year undergraduate supervisor exposed me to this thing called molecular self-assembly, and I thought it was really cool, and realized that you could make materials out of this, did a PhD out west, and then landed in the US and kind of kept building my skill sets in this area. And then I landed at a place called the California Nanosystems Institute, and then when I went to go interview for jobs, one of the things I really found exciting about Xerox Research Center of Canada is that really about taking new and cool materials and trying to commercialize them, which can be difficult, but really, really interesting work.
Very good. So Christie and you see Xerox, and I'm actually just sitting here thinking, I didn't quite realize all 4 of you were UW grads, so that makes me really happy. Okay, so wonderful introductions. You can now see why we have assembled this panel, and what's nice about it is it covers the full spectrum, from materials to electronics to photonics, agricultural, natural materials. We've got small companies right up to the largest companies, and everybody's thinking global. So you've got a fantastic panel. So remember those questions in about 30 minutes. But, you know, translating from, let's say, Mark's presentation where you had this wonderful understanding and a bunch of applications, the rain sensors, and even implored you, think about it. And there was everything, including shower curtains and other things. But this is obviously where the rubber hits the road. They're in there. They have metrics around product introductions and profit and money. And this is where innovation really has to be focused. So we're trying to translate over to that. So the first question is going to be if the university is, we've got a Waterloo Institute for Nanotechnology. That's a research institute. Here's a world-class researcher right here. The other thing is transferring that knowledge, you're creating knowledge, into these heads who are going to ultimately be the employees. So that's what we do, and you're the receptor capacity for it. So the question I have is around partnership and collaboration between academia and industry. So you can take it either way. What are the key success factors or the challenges in creating these kind of partnerships? How do you build successful partnerships in innovation? That would be my first question. And let me put it towards someone. I'll actually choose Dr. Van Balaglui. You get to lead off. Okay. Go ahead.
Well, thanks, Alain. I think one of the most important things, if you really want to be successful in driving partnerships, is to look at organizations that embrace open innovation. I'll share a little bit of the journey that EcoSynthetix was on. When we were a small embryonic company, we realized we thought our technology was everything, and we weren't going to talk to anybody, until we had everything patented. And we realized through that journey that that's maybe not the most efficient way because it takes a long time, and you have to. Small companies don't really have the resources to drive new technologies in a big way. So then we took a dramatically different course and really started to really embrace open innovation, work with a number of great academic institutions. We have a lot of collaborative projects with University of Waterloo and some other Ontario universities as well. And we think this is a great way to do a lot of our fundamental research development. And we, pit the knowledge that our senior scientists have, which tend to be a little bit more application-oriented, to those academics, which tend to be a little bit more fundamental chemistry and fundamental science-oriented. And it really leads to a powerful combination. The other thing I would stress, really to drive innovation, is to make sure that you have the senior management of the industrial partners completely on board and committed to it, because they, of course, drive the resource allocations and the funding, and so that's critical. Another very important element, I would say, would be the whole funding aspect. So maybe for a larger company like Xerox, you've got a lot of resources at your disposal, but then for smaller companies, you maybe don't have the same kind of funding capability, and that's where organizations like NSERC and OCE, Ontario Centres of Excellence, they all bring very, very critical support to the whole process. So I think sort of those three elements: getting the right kind of mentality and framework with the industrial partner, one to embrace open innovation, getting the right combination of strengths with an academic partner, and then providing the fuel, if you like, through a good funding agency. And those are a very powerful combination.
Okay, thanks very much. I heard everything from open innovation, of course, right through to the fuel or the funding, right, and keys that they can think about as they go forward. How about Simon?
Sure. So from the point of view of the company, what we need in order to have a successful collaboration is a good fit. And that starts with the academic partner thinking about and understanding what they're bringing to the table as well. Industrial research and academic research are, in some ways, we can at least speak the same language, but in many ways fundamentally different. Academic research has this wonderful freedom to just follow the mystery and follow the interest to see where it leads. But industry is a bit more constrained than that. We've got to make money eventually. And that it needs to be understood, and we need to understand it as well as industry, that there's a little bit of a disconnect there. We need to be able to work through that and figure out what both sides are going to get from the partnership, make sure that both sides are benefiting from it, that it's not a case of we're just asking for some contract research. We'd like it to be a lot more interactive than that. The governmental organizations that Peter mentioned, Christie's taken advantage of those as well. We've worked with NSERC, and we've worked with MyTax, and we've worked with OCE. We've had some very successful collaborations with the University of Waterloo, we've worked with McMaster, we've worked with U of T, we've worked with Queen's, we've worked with McGill and UBC. There are a lot of really good programs across the country, and we've benefited a great deal from that. One thing that you really need to help us with is helping us with the academic culture. Understanding and getting things to work in a university environment is very different than getting it to work in a small or medium-sized company, where maybe we don't have quite the same set of policies that a university does. We get frustrated sometimes when we want to install a new piece of equipment, and we even want to pay for it, but the university somehow manages to take 6 months to get it in and get it installed. You need to help us through that, and that can really help us with our collaborations as well. But those are a few comments.
Fantastic. Where do you want to put that equipment? Bring it here. I'll get it in tomorrow. I'll choose. Please, Dr. Sarkar.
Yeah, so I guess there's two things I could add to that. I'm sort of straddling the line between industry and academia, so I have a sort of unfair perspective here. So I'd like to focus on what I think the U of W is actually doing right to encourage companies to fund the research and also to encourage startup companies. So the first thing is Policy 73, which I'm sure a lot of you guys are aware of. It allows the researchers to own their own IP. So the university not only allows you to own your IP, but will support you in patenting things financially and through legal counsel. And another thing is that the U of W really tries to have an open for business kind of angle on most of their facilities. So for instance, the SURF lab and the G2N labs here are actually structured as user facilities with hourly rates for use of equipment as well as assistance on that equipment. So I think that really does encourage industry to have a presence on campus. But I do also share some of the concerns about the difference in mentality of a researcher doing research for the sake of discovery and for the sake of obviously profit motivation. So one thing that's really helped us is to have a presence on campus, and for larger companies, hiring a postdoc through the MyTax program or hiring PhD students and really interacting with them on a quarterly basis to make them understand that they have the freedom to perform research that they're curious about, but that your company has a mandate as well, and if there's any sort of overlap in that Venn diagram, then there's more likelihood of success.
Fantastic. So we go from a smaller startup company that's driving innovation locally to, I'm going to go right to a global leader in innovation right around the world. What's your perspective?
So yeah, the 500-pound gorilla company. But what's interesting is that large multinationals are realizing that the model of innovation where you start everything internally, put your shoulder behind it and drive it through all internally and minimally looking outside for help, those days are over. And actually, if you listen to a talk, there's a number of them online by the CEO of our sister research center in California called Park. He'll talk about this new model of innovation where large multinationals like Xerox will search out like tentacles for strategic pieces of help to bring the product to market, and that's really the only way to compete, because we don't have all the best ideas. We have great capability in some areas, but we don't have all the best ideas, and so we want to find folks with the best ideas, and obviously university and academic institutions have those. So I completely agree with everything that's been said by the other panelists. Maybe something I can color it with a bit is when in doing that, you need to think about intellectual property. And I realize that this is sometimes a topic that is difficult to talk about, but if you can take a time and just really understand what the intellectual property is that you've created, package it up in smart ways, be it a patent or a group of trade secrets or whatever, and then realize also that the way you work with a company is through a set of rules, right? Where called an agreement, where you share the profit or the reward of going to market and commercializing. So, and that this needs to be a delicate and balanced discussion, and it's just a natural part of business. It's a natural part of commercialization, and if you can get ahead and putting your mind on topics like that too, in your spare space of studying and doing research projects and going through exams, I think that's a very worthwhile exercise, because if you're equipped with that type of knowledge and language, you can work with large companies and other companies in a much more efficient way.
Thank you very much. I'm just, in summary, looking at a few things, starting off with open innovation and the funding that drives it, but also we heard about fit, not just technological fit, but perhaps even relationships and fit. You've got to be able to work with each other. We've heard about some challenges as well, right? But I think there's the opportunity as well, right? The opportunity to come up with new ideas. And I love the finishing segue. You certainly talked about the nuts and bolts of IP. You can't move forward without getting your head around that. But at the end of the day, you mentioned this phrase, but where do the new ideas come from, or strategic pieces? And I noticed the Dean of Science was sitting there, and there's probably a bunch of people on campus with something like, this is where new ideas come from. another plug for UW, but any research organization, really that's where the new ideas come from. And we have the same thing when industry comes to see us at WIN. I sometimes ask them, they're the largest companies in the world, and why are you here? You have everything. And they said, well, we don't have all the ideas. So I think that's a wonderful point to end on. Thank you very much for answering that question. Okay, I have 6 questions here, but I actually circled one here that I thought was probably the most important in everybody's mind, and it was, are you hiring? And then I went ... and I said, but rather, perhaps a better answer or a better question is, can you tell them a little bit about the skills, the training, the background, what's important for success to get into the industry? A lot of them are probably on co-op, so you could probably answer it 2 ways. One is when they graduate, what is the opportunity? But also when they're co-op, what's the first thing you want to do in the first 100 days? What are the skills? It may not just be perfectly technical skills. So this really is a skills and training-based question, and that's it. Tell them about the types of training or skills that are important for success in your industry or any high-tech job for that matter. Let's start with Neil.
Sure. So we actually do hire co-ops, and we have hired some full-timers, both actually nano undergrads from Waterloo. And this term we actually interviewed 8, and I wish we could hire all 8 of those candidates that we interviewed, and it would be pretty awesome to have just an army of co-op students doing all of our work for us. But unfortunately, we're a startup company, we're resource limited, so we have to be pretty selective. I would say that some of the things we look for is a creative sense of technology, which I think this program kind of really teaches everyone here. In a startup environment, sometimes you just got to get the job done. So we look for people that are versatile and that are willing not only to do things that they're interested in, but also to get their hands dirty in the lab. But I think being in this program and seeing what your resumes look like through the co-op process, you're already doing a lot of the right things.
Okay, thanks very much. Peter.
So I can echo a lot of those comments. We certainly have an interest in candidates who have just sort of exude a very natural curiosity about how things work. I think we very much like to see people who really can think out of the box, look at ways to drive for new solutions rather than accept the status quo. Then there are some other attributes that we also look at, which are maybe a little bit more specific to EcoSynthetix. Due to the nature of our business undertaking, we like to see people who've got some good knowledge in the area of polymers, polymerization processes, cross-linking techniques, because without that, you're a little bit handicapped, and I think versus others if you don't have that kind of background. So that's maybe a little bit unique to EcoSynthetix or other companies that operate in similar areas to EcoSynthetix. But then some of the general skills, which I think will be valuable for you throughout your whole career, is just to have really develop excellent communication skills. Whether you're taking your project and discussing it with a senior scientist at the company, or taking that project and discussing the results with the CEO, it's quite a different discussion. And you just have to know how to tailor it properly. So I think some people just have natural communication skills. Others maybe have to work at it a little bit more. But I mean, those are kind of the key things that we look for.
Fantastic.
Well, to answer the first ... question, we're constantly hiring, but right now we've got to push on for software and for production staff. So maybe not nanotechnology at the moment. But after Alan asked me to join the panel, I realized we have 2 nanotechnology graduates working at Christie right now. And they're classes of 2013 and 2014. Both of them started as co-op students at Christie, and they were both hired by the fellow that used to be our chief scientist, though he's now retired. And so I talked to them a bit about what nanotechnology gave them that allows them to succeed at Christie, and they're both succeeding in excellent and sometimes unexpected ways. They started describing the program and what it gave them, and I started feeling good about myself because they were describing a lot of the things that I would use to describe physics when I did that in the 90s. And that is a tremendous breadth of experience that you don't come out knowing absolutely everything about one tiny little piece of the pie. You know a lot about a lot of different areas. It's a lot of materials science, but it also comes with programming and simulation experience. It comes with chemistry. It comes with physics. And so for some of the discussions that will go on at Christie, you'll find yourself the expert in the room, and for everything else, you'll be the second most expert person in the room, which is a wonderful place to be in. And that breadth of experience is something that's important to Christie because we are a very multidisciplinary, collaborative operation. That a projector, it's, well, you've got to generate light, and to generate light, you have to understand some of the physics that are going on inside of the lamp, in this case here, but inside of phosphors, inside of lasers, inside of quantum dots as well that Mark mentioned a few minutes ago. But you also have to understand that these light sources are going to generate a lot of heat, and how do you get rid of that heat? And well, you've got to drive them electrically, and so how do you do that? And so this breadth of experience is really important to us. Now, something else specific to nanotechnology is that at least my part of industry, we're only just becoming aware of nanotechnology and the nanotech engineering program. And we're still trying to figure out what this new toy can do for us. And so we would really appreciate your help in understanding that. And that means you've got to pitch yourselves to us. You've got to communicate your strengths to us and help us understand where you fit inside the company.
Yeah, I would agree with everything that's been said. I think, you know, are we hiring? Yes, we are. I think we have a few jobs. If you want to look, just look at our LinkedIn page and follow that. But I'm just thinking back to the recent set of people we interviewed over the summertime, and one of the things that I was really looking for was people who were industrious. You know, people who would get in there and do what needed to be done to get the project completed or get the product out the door. And so, like, for example, we hired actually someone from this program, and it turned out the first week wasn't to do anything in the lab in terms of making materials. It turned out to be figuring out how to program something. So sitting down and figuring that out. And so it's just kind of echoing a lot of having a breadth of experience, having been exposed to a variety of experiences, and not necessarily being an expert in every one, but being willing to engage everyone, but also being very, very good at one thing at least. You know, be an expert in this particular field of technology, and then be willing to kind of grow that out to the side. And so if you look at the sort of the talent or HR words around this, it'd be called T-shaped experience, right? So that's really something that we look for, and certainly I do too. Yeah.
Fantastic, thanks. Again, just looking at a couple of points, I heard get the job done like 3 times there. So get it done, can-do attitude for sure. Yeah, the creativity around thinking out of the box. I like the know your audience side. You know, that's true. You've got professors up front and that's it. But at a company, multidisciplinary, different levels, different communication skills going out there. And I heard about breadth. I like that as well. Breadth, but the T-shaped. Know your business, but be able to go broad. I hear that T-shaped example, that HR skill set a lot. The other thing, the idea of pitching nano. You know, these guys, none of them would say they're a nano company. You know, in semiconductors, you know, they call it deep submicron engineering. Call it nano, right? You got photonics here. You've got, you might just say, we're toner and materials. It doesn't say nano, but it's all at that scale. So I think that's an important consideration. So in fact, you have to be evangelists is what I'm hearing a bit, trying to show the benefit. You know, you're in fact going to be the experts as you roll in, or at least provide the insight. And the other thing I wrote down is no one's going to look at those projectors or those Xerox machines the same ever again. I'm never going to. There's a lot going in there. Okay, love that question. Running out of time, you know, this really is interesting and can go on forever. I want to leave some time for questions, but I'll ask one more that will run across the panel before we open it up. And it's about startups. So it's all the rage right now, right? Everybody's looking to do a startup. At least at Waterloo, it's especially a focus. But it's more than just a startup, like starting a business. It's entrepreneurism and the entrepreneurial spirit. And that can be different. And the reality is we've got the full spectrum, as I say, on the panel here, from startup right through to a very innovative company. So the question I have then for the panel is, from the company's perspective, what is being an entrepreneur? What is entrepreneurial spirit within your organization? And if you are a startup, though, what does it take to be a success if you're actually an entrepreneur in a startup? And so that being said, we'll start with the startup again. We'll come back again. Let us know, and we're going to progress all the way up to entrepreneurial spirit in a large company. Go ahead.
Yeah, so you should probably take all of this with a grain of salt, because we're not a successful entrepreneurial venture yet. We're still just starting to sell product, and we'll know in a few months, actually, if our Kickstarter campaign is successful. But I think there's a lot of definitions of entrepreneurship. The one that I have here is a person who starts a business and is willing to risk loss in order to make money. And the risk thing is kind of one of the big differences between being an intrapreneur. So when I was in industry, I tried to always work on the cutting edge of what we were selling, try to come up with some new products. The difference between being an intrapreneur and what I think I'm experiencing now as an entrepreneur is it boils down to risk, which manifests in my case as fear. So, in industry, I think we had problems with instruments going down, and sometimes we're trying to ship product and some tool was getting flaky. And I wouldn't really lose sleep over it, because I knew the process engineer would figure out a way to tune the process back and get us back into production. Whereas today it's basically you've created a job for yourself as an entrepreneur, and it really is a job. It's nothing more glorious than that. And so when the reactive ion etch tool goes down, I do lose sleep. So that's something I think you need to consider as the risk. And the other thing is, instead of deciding that you will be an entrepreneur and then try to fill in those shoes, I think the important thing to focus on is to treat it as a job. So you got to find a problem in industry. You got to design a product that solves that problem. You got to raise some funding, and then actually market your product and win over some customers, which is a job that takes quite a bit of time to get through all those steps. And then one day you'll wake up and realize that you're kind of doing what the definition of entrepreneurship is.
Fantastic, right from the front lines.
Well, I think the way I look at entrepreneurism is sort of like on a pendulum, where one end you've got an organization that's super highly entrepreneurial, and then when you go to the complete other end of the pendulum, it's an organization that is highly bureaucratic. And in my view, an organization that's very highly bureaucratic, it tends to stifle entrepreneurial spirit. And so that's one thing that EcoSynthetix has spent quite a bit of time on, is making sure that as we grow into a larger organization, that we try to free ourselves of excessive bureaucracy. You're going to need some as you become a larger organization. You need more structured processes and everything like that. But we try to keep it at a minimum so that we can keep ourselves as far over on that pendulum of high entrepreneurialism. The other thing that I think is important is kind of like the mentality that people in the organization have. And the one key thing is not to be afraid to make mistakes. In certain organizations, I mean, if you make a mistake, especially a significant one, it can be career-ending, or it can be at least significantly career-changing. And we've tried to say, on the path to entrepreneurialism, mistakes are going to be made, and it's almost like we embrace them. We're going to learn from them, we'll strengthen, and it'll point us in the correct direction as we move forward. But we don't really penalize. We don't want to be an organization that penalizes people for having gone down the wrong path in the spirit of entrepreneurialism. So those are two considerations.
Has to be a balance, right? Embrace failure, but not too much.
Yeah. We don't embrace catastrophic failure.
Fantastic, Simon.
I've never been very happy with my thinking on entrepreneurship. I don't think it's very well developed and certainly not good enough to publish anywhere. But I think some of the thoughts that I have around it are, and it's about ideas and trying to get your ideas to an endpoint that satisfies you, that makes you feel like you've done something with those creative thoughts that you've had. And some of the key ingredients along the way is you've got to be your own best champion. At least at the very beginning, you have to be, because nobody else is going to do it for you. They're not going to just pull you out of a crowd and carry you through to the end. You've got to step out of that crowd on your own. At the same time, you've got to be your own worst critic as well, because if you're not challenging yourself, you're not going to be ready when everyone else challenges you. Be prepared for that. And then ask for help. Not only don't be afraid to accept help, but go out looking for help. Find the community that's going to help you be successful, whether it's in a company, and maybe you're looking at other parts of the engineering organization, or maybe you're a startup and you're in a community like Waterloo Region that has just this spectacular startup culture and has so many support structures there that you can take advantage of. And I'd point out things like Communitech and the Accelerator Center not far from here, and Velocity and the incubators that are in the community. Go out and find the place, the environment that's going to make you successful. Don't wait for it to grow around you, because it won't.
Yeah, I echo a lot of the things here. So I guess in a big company like ours, we're 140,000 people spread around the world. So we're the size of a small city in a bunch of buildings around the world. And so to be able to do something intrapreneurial or entrepreneurial in a company requires, I think, a lot of the same things you want to do if you want to stand up your own company, right? You have to be able to communicate it effectively in small snippets. But just to shift a little bit, I think one of the things I learned and I got put in the penalty box for was really standing up for a technology that was really good technology, but it wasn't good business, right? It was commercializable, but it wasn't good business for Xerox. And so after a few months, there was an opportunity where we saw, we had this really great idea to create a really differentiated service. And so one of the things I always heard was, Adrian, are we going to make money? How are we going to make money? And how are we going to do it? And when are we going to make the money? So it's the same problems that any startup feels, right? So, and then how are you going to do it? Like, who can do this? Where are you going to get the funding internally to do this, et cetera? So I found a friend, and a friend found me. And so actually it was a salesperson who really knew the customer really well. And it was me who knew the technology quite well, and we fumbled our way through it. And I think one of the things I learned in my company was that find someone high up, but not too high up, to give you some air cover. So you get some leash and you get to go and make your mistakes, and then if you make your mistake, not everybody sees it. And then you slowly get better and better and better. So long story short, that turned into probably one of the best projects in my career that is putatively $1 billion opportunity for Xerox, but it's just really at the early stages. So we've got to, we'll pilot next year, but it still needs all the attention. You've got your first prototype, you got your first product, but you just can't sit and watch it. You need to really shepherd it and really think about it, just like you're growing your business. But the difference is I'm not mortgaging my house. I'm just risking my career path and development, right?
Not risking house.
Not risking house. But some folks have the tolerance for that, and we should give credit to those folks. Yeah.
That entire panel question, I don't think had a word of nano in it, but it was probably the most insightful, experience-based, insight you're going to get probably for the next few years. I thought that was incredibly insightful, and dovetails nicely with moving ideas and people into the economy. So that's part of it. I have a couple more questions, but we really only have 10 or 15 minutes. So you must hear from the audience. We want to hear from you. So I'm going to open the floor and save one last rapid fire question to finish this off at the very end for the panel. But let's open it up for the next 10 minutes or so. Let's get some questions for the panel. And do we have mics, or can you just speak really loudly? Can you? Okay, go ahead.
All right, so have big monopoly, big money, unlimited funding for research, and for pure research anyways, and that everything needs to be monetized in the next 5 years, and need to make, if you're not making money off it, it's not worth doing. But it seems that like this industry specifically is something where pure research is really necessary, because places like the Silicon Revolution, that Bell Labs kicked off, that was mentioned earlier, or like the GUI and object-oriented programming language and computer-based language that Xerox PARC kicked off 30, 40 years ago, wouldn't have been possible without pure research. So like, where do we start a field, and how much pure research do we put in, and say that this is the amount we need to research before we can start monetizing things? Because it seems like we're throwing to the wayside pure research to make quick money.
Are you directing it at a particular panel in general, or?
The panel in general, but I suppose the gorilla in the room, Xerox.
Try not to insult the panelists.
He's the best. He might have the most relevant.
Yeah, sure. So we'll throw it to Dr. Cote.
Okay, I get this question a lot. You know, there is a book about Xerox called Fumbling the Future. But anyway, I guess I agree and disagree with your thought. So in the examples you cited, every one of those projects were geared towards trying to make a technology and build a product, right? It's characterized now as pure research, but it had an intent to make money at some time. Now, I don't think we throw away pure research. I think sort of the way the world is going right now is that the pure research is much more shifted to the universities and academic institutions, and then they're being pressured to think more in an industrial and commercialization sense. So it's not a simple, I don't think it's being thrown away by our innovation ecosystem in this country. It's being shifted more to the academic institutions, and because the real honest pressures of big companies like Xerox is that we're publicly traded companies. The reality is that every quarter we need to report to shareholders. You know, last quarter wasn't a great quarter for Xerox, so we gotta find ways to make money and making sure we're converting new technologies. So those are the sort of the pressures, but don't think that companies like Xerox don't appreciate pure research or fundamental research, however you want to talk about it, or what words you want to use to describe it. Everybody's really paying attention to it and just trying to find the right ways to integrate it and commercialize it. So,
okay. Any other questions from the audience? You'll have to speak into the mic.
I can talk fairly loudly.
I think they need to record it.
Oh, okay.
Pass that up to her. Thanks.
So I guess this question is more in regards to working with universities. So the direct question is directed at any company who's currently working in tandem with a university. I know that companies do come to universities with ideas and look for the university to develop that solution, but sometimes it feels like that solution isn't feasible, and the universities feel pressured to bring results that aren't necessarily there. So in terms of working with a university, how do you guys kind of accept failure in terms of the idea? Like, is that something that like the universities are allowed to do? Kind of, yeah, that's the question.
No, I'm just kidding. I think, I mean, I'll just take a stab at this. Clearly, we operate on campus and we have a lot of close collaborators here, but I think it would be a better answer to your question to hear from a larger company. But just my 2 cents here. I think we have to distinguish between high-risk research and incremental development. So within the company, when you're trying to make some incremental improvement to your product to remain competitive, it makes sense to do that type of R&D in-house. If you're looking at game-changing innovations, you have to be willing to take some risk, and that type of high-risk research traditionally has been something that's assumed in academia. So I think it's unreasonable for a company to expect to take a big risk and explore some fundamentally new ideas and then get angry about failure. Because that's, that companies maybe these days are no longer structured the way that Palo Alto Research Center, they failed at a lot of things and they kept funding until some things became successful, but you don't see that as much in industry today.
Anyone else? Maybe I can just expand the question to say, I've seen successful partnerships, and they've stayed on the rails probably because of a lot of structure and because of relationships and because of a lot of other things other than the actual research, common goals. I can think of a couple of people on the panel who've had good experiences. Does anyone want to comment on that? Sure. Or
Go ahead. Okay. So I think one of the things that is really important in any kind of industry academic collaboration is just common understanding at the onset of the project as to what the desired outcome would be. And one of the things that EcoSynthetix is increasingly pursuing is, before the project gets truly into its implementation phase, we'll put together some of the key hypotheses, like technology hypotheses, that we may have in regards to the project. And these are the important points of information that are relevant to EcoSynthetix and how we potentially want to market this product going forward. So whether the project is going to fail or not in meeting some of its performance objectives, we don't know, because by its very nature, research has a lot of unknowns associated with it. But at least up front, we're going to communicate and say, these are the important hypotheses that we want you to test as you're driving this program through. And as long as we get answers to those questions, that is of value to us.
So the context of our collaborations often goes something like this. Christie will look at our roadmap of products for the next few years, maybe 2 to 3 years in the future, and we'll say, well, look, we're sort of hitting a wall on this particular technology. It's going to be a limiter to our continued push forward. And we don't know how to fill that knowledge gap. We don't know how to replace that technology. And we certainly don't have the fundamental research capabilities that it would take to fill the gap. And so my group is mandated to look beyond the current roadmap, to look for the technologies that are going to fill those gaps for us down the road. We understand that it's a question mark, because if it weren't a question mark, it would be on the roadmap. And so there's an organizational understanding that if you don't know what the answer is, you can't be too disappointed when you do find out that the answer isn't something that you liked. So failure isn't catastrophic, or at least one failure isn't catastrophic. A string of 5 failures in a row might start worrying a lot of people. But yeah, sometimes the answer isn't going to be what you expected. And that's life.
That's major research.
So,
thank you very much. What I'm going to suggest is eventually, very shortly, we'll be going to a coffee break. You'll be able to corner them and riddle them with your questions and ask them to hire you. But I want to throw one last question with like a minute or two left here. And what it is, it's going to be really focused. It's for each one of them, looking for, it could even be a 1-word answer, a 2-word answer, but not much more than a sentence or so. And it's your parting advice to the audience, right? It's advice. So what parting advice would you give to these guys? And most of them, I assume, are all of you in the Nano undergrad program. Put up your hand. Look at that. Okay, so we've got, the next generation of sort of interdisciplinary advanced materials engineers. You guys are in that area in terms of the industry. So the question is, in a word or two or a sentence or two, what parting advice would you give to the students if you were them? And yeah, it looks like you're about to jump in, Simon. You can lead.
So my word is community. Just echoing what I was saying earlier, is that find the people and the organizations that complement you, that help you get towards the success point that you want to be at. That's it. You're not going to get anywhere on your own. It doesn't work that way.
Yeah, I totally agree with that. I was going to say network. I hope you've already started to develop your network now, but also put yourself in sometimes uncomfortable situations, like go to that conference and you'll have a chance to meet people. And from that, you're going to develop new contacts, new knowledge. So I would encourage that.
I would say stay in school. Let me just elaborate a little bit. When I started up a company, a lot of people, investors, told me you need to get off campus ASAP because it's just kind of stifling your productivity. And over the years, I think I've run into savvy investors who say the opposite. And being on a campus like this does actually, I think, help to get you to the point where you can actually start shipping product. And at that point, I think there's reasons to not be in school anymore, but yeah, stay in school.
Stay in school.
Final word.
Keep learning. In every situation, be it learning technology or science, but also in the way you see businesses operate or businesses that you experience. And I think the other big one is as you grow your network, which I completely agree with, is be credible, right? So build your credibility, not just in terms of your skill set, but also in terms of the way you formulate your business relationships. If you say you're going to do something, do it. You know, just credibility is huge.
Go big or go home.
Yes, that also helps too.
Dr. Neil Sarkar from ICSPI Corp, Dr. Peter Van Balloy from EcoSynthetix, Mr. Simon Guthrie from Christie Digital Systems, and Dr. Adrian Cote from Xerox Research Center Canada. Please thank them.